Hi ladies, it's Mr. O'Sullivan. Today we're looking at lesson 5-5a, Systems of Equations by Graphing. Today's learning target is, I can solve a systems of equations by graphing. The definition of a system is two or more equations that need to be solved simultaneously, aka at the same time, and the solution is the point that makes both equations true on a graph. It's their intersection point. So what we want to look at is we want to see where our lines are intersecting. So for instance, if I have a graph right here, I'm just going to draw a quick sketch. Like pretend I have a line that looks like this, and then a line that looks like this. I can say that this is their intersection point right there, because that's where the two lines intersect. So example number 1, is the point 2,5 a solution to the systems of equations provided? Well, we looked at this yesterday, and all we do is we simply just plug in this point into my x and y values for both equations. So what I do is I organize this. So I have that system, y equals 4x minus 3 and 2x plus y equals 9. What I'm going to do is I'm going to rewrite my equation. So I have y equals 4x minus 3. And everywhere I see a y, I'm going to substitute a 5. And everywhere I see an x, I'm going to substitute a 2. So now I just do some mental math, and I want to have the same number on both sides of my equal sign. So I do the math. 4 times 2 is 8. So I have 5 equals 8 minus 3, and 8 minus 3 is 5. So right now, this is a solution, but we need to make sure it works for our second equation as well. So we now have 2x plus y equals 9. Again, where I see that x, I'm going to substitute a 2. Where I see that y, I'm going to substitute a 5. And now I do some mental math. 2 times 2 is 4. And 4 plus 5 is 9. So since I have equality, this is a solution. And that's your final answer. Example number 2. Solve the following systems of equations graphically. We have y equals 2x plus 5 and y equals negative x plus 2. The first thing we are going to do is we're going to look at our first equation. So we have y equals 2x plus 5. And we remember that the number attached to our x is our slope. So m is equal to 2. But what I'm going to do is I'm going to put that 2 over 1. So 2 is my rise and 1 is my run. We have to go back to what slope is. My y-intercept is 5. So the first thing I'm going to do is I'm going to plot a point at y equals 5. So 1, 2, 3, 4, 5. And I'm going to plot a point right there. And now I'm going to go up 2 over 1, because we always go to the right. 1, 2, 1, plot a point. 1, 2, 1, and then I run out of room if I go up here. So I'm going to go back to my y-intercept and go down 2 over 1. So down 2 over 1. And I keep on doing that until I run out of room. And then I run out of room. And then I draw a line going through my points. As best as you can. Use your Metro card, all right? Now I have y equals negative x plus 2. What I'm going to do, though, is I'm going to put a 1 in front of that negative 1x. That way I know that my slope is negative 1. So my slope is negative 1 over 1. And again, negative 1 is my rise, so I'm going to go down 1, and then I'm going to go right 1. And my y-intercept is 2. So I'm going to plot a point at 2. And I'm going to go down 1 over 1, down 1 over 1. And if you look, my graph doesn't hit or cross each other or intersect each other. So now we have to go backwards. So I go back to my y-intercept. Instead of going down 1, right 1, I go up 1, left 1. And if you look right here, I'm going to intersect. And then I draw a line going through my points. So this is my final answer. Negative 1, 1, 2, 3, comma 3. That is the solution to the system. So now we want to check our answer. So all we're going to do is everywhere we see an x, we're going to substitute negative 1. Everywhere we see a y, we're going to substitute a 3. So if we look at our first equation of y equals 2x plus 5, I'm going to plug in negative 1 for x. So I have 2 times negative 1, and we're saying our y value is going to be 3. So 2 times negative 1 is negative 2. Negative 2 plus 5 is 3. So that works right now. Now we're going to look at our second equation where we have y equals negative 1x plus 2. So I'm going to plug in that negative 1 for x. And that 3 for y. We know negative 1 times negative 1 is 1, so I have 3 equals 1 plus 2, and 1 plus 2 is 3. So 3 is equal to 3. So this works out. We did this problem 100% correct. Question number 3. Solve this system by graphing. We have y equals negative 5/3 x plus 3, and then we have 1/3 x minus 3. So we have y equals negative 5 over 3x minus plus 3, I mean. Our slope is the number attached to our x, so in this case it's negative 5/3. And our y-intercept is 3. So I'm going to plot a point at y equals 3. And I'm going to rise negative 5, so I'm going to go down 5 and run 3 to the right. So go down 5, right 3. 1, 2, 3, 4, 5. 1, 2, 3. 1, 2, 3, 4, 5. 1, 2, 3. And I run out of room. So I go back to my y-intercept, and now I go up 5, left 3. 1, 2, 3, 4, 5. 1, 2, 3. And I run out of room. So now I draw a line going through those points. Doesn't go through this one, but I know it does. Now I'm going to graph my second equation. So my second equation is y equals 1/3 x minus 3. So my slope is 1/3, and my y-intercept is negative 3, because that's the number hanging out by itself. And again, we're rising 1, running 3. So I plot my y-intercept of negative 3, so 1, 2, 3, and I go up 1, right 3. So up 1, right 3, up 1, right 3, 1, 2. And then I go back to my y-intercept, and I go down 1, 1, 2, 3, 1, 2, 3, 1, 2, 3. And I draw a line going through those points. And if you look, I intersect right here. So that's my final answer. So I go out 1, 2, 3, 1, 2. 3, negative 2 is my final answer. And that's it for today. If you have any questions, email myself or Ms. Townsend. Have a great day, ladies.